Hello and welcome back to Math with Mrs. Becker. Today we are looking at college algebra and we are moving on to Chapter 1, Section 7, which looks at linear models and scatter plots. Many real-life situations involve finding relationships between two variables. In a typical situation, data is collected and written as a set of ordered pairs. Now, when you graph that set of ordered pairs, what you get is something called a scatter plot. Now, when you're graphing a scatter plot, you do not connect the points. So let's go ahead and create one now. The data in the table shows the outstanding household credit market debt, and this is in trillions of dollars, from the year 1998 through the year 2004. Construct a scatter plot of the data. Create a set of ordered pairs representing the data. Let T represent the year. T equals 8 is 1998. So what that means is that T equals 0 is 1990. Because the T equals 8, if that's 1998, this means 8 years after our base, which would in this case would be 1990, 8 years after the base would be 1998. Okay, so they want us to create ordered pairs. So 1998 is 8 years after 1990. The debt was 6.0 trillions of dollars. 1999, the year I graduated, that's 9 years after 1990. It's 6.4 trillions of dollars. 2000, that's 10 years after 1990. The debt was 7.0 trillion. 11 years after 1990, the debt went up to 7.6. 12 years after, 8.4 trillion. 13 years, 9.2. And last but not least, 14 years, so 2004, the debt was 10.3 trillion. Now what they want us to do is use these ordered pairs to create a scatter plot. I'm going to go ahead and do that. So I'm graphing, and remember when you make a scatter plot, you just put a coordinate for each ordered pair and we do not connect them. My x values, notice that we started in 8. I can include what's called a break symbol. If I put a break symbol there, what that means is that I can skip right to a different number. I do not have to start at 0 and go 0, 1, 2. This break means that you're skipping numbers. I want to start at 8. 8, 9, 10, 11, 12, 13, 14. And what are these values? They are years after 1990. You always want to label your graph so you know what it is that you're looking at. Now, if I look at the y values, again, I'm going to use a break symbol. I don't want to go 0, 1, 2, 3, because my lowest number is a 6. So again, do that little break symbol. What that means is that you're skipping values. I want to start at 6, so I'm going to go 6.0, 6.5, 7.0, 7.5. I'm going way up here. I'll be off the grid. 8.5, 9.0, extend it. We'll go 9.5, 10.0, 10.5. Now, when you're graphing your scatter plot, all you do is put a point for each ordered pair. So 8 years after 1990, the debt was 6 trillion. There's my point. 9 years, it was 6.4, so just under the 6.5. 10, it was at exactly 7.0. 11, it was at 7.6. 12, it was at 8.4. 13, it was at 9.2. 14, it was at 10.3. So here are my coordinates. That is a scatter plot. Don't connect them. When you have ordered pairs in the form xy, okay, so you just have a collection of ordered pairs. If the y values tend to increase as x increases, what that means is as x gets larger, as you go to the right, y goes upwards. So if x increases as you go to the right and y tends to increase, you have what's called a positive correlation. Okay, now in reverse though, okay, so here's a visual. This is positive. As x gets bigger, y also gets bigger. Well, as x gets larger as you go to the right, if your y values tend to get smaller, you have a negative correlation. So correlation is just the relationship that occurs between the two variables. So if it's positive, as x gets bigger, y gets bigger. That's the trend. Not every point has to match that. That's just the pattern that typically occurs. Here, as x gets bigger, the y value tends to get smaller. Now, if you don't have either of those, they call that no correlation. What that means is that there's no real relationship between those two variables. You can't use one variable to try to make a prediction of the other. So let's take that and go ahead and look at a scenario, okay? On a Friday, 22 students in a class were asked to record the numbers of hours they spent studying for a test that was going to be on Monday, okay? So their homework was to record how many hours did they study for the test over the weekend. The number of hours that they spent watching television during the weekend, okay? How's that for a homework assignment? Okay, guys, on Friday, I want you to keep track of how many hours you studied, and I want you to keep track of how many hours you watch TV. And then Monday, we'll see how you do with the test. That's what their homework was. The results are shown below. The first coordinate is the number of hours, so that's the x. The second coordinate is the score, the percentage on the test. So we have to create a scatter plot for each set of data. So we're going to go ahead first and start off with study hours, okay? If I look, the hours studied, somebody had 0 all the way up to 10, okay? I'm going to go ahead, make my scatter plot. I am not including a break symbol this time because somebody did study 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is hours studying. Now, if I look at the percentage, there's a 40 and there's a 98. So if I go 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Perfect. I'm going to do a break symbol. And I'm going to start at 40. So 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. That is the percentage that they scored on the test. So if I'm making a scatter plot of this, you do the same thing. You go one order pair at a time and make a point. 0 hours studying resulted in a 40% on the test. 1 hour studying was not much better, it was 41. 2 hours, 51, so it was a jump, but that's still kind of stressful. 3 hours, a 58. 3 hours, a 49. 4 hours, a 48. Okay, this test must have been really hard. I wonder what they were studying. 4 hours, a 64. 5 hours and a 55. Okay, now let's think about this. Let's say over the weekend you studied for 5 hours and you still scored a 55 on the test. I would cry. 5 hours, 69 on the test. 5 hours, 58 on the test. Lots of people study for 5 hours. 5 hours, 75. I was starting to wonder if anybody was even going to get up in the 70s. 6 hours, 68. 6 hours, 63. 6 hours, 93. Yeah, that's good. 7 hours, 84. 8 hours, 90. 8 hours, 76. I hope you're doing this with me. This would be really boring to watch if you're not participating. 9 hours, 95%. 9 hours, 72%. 9 hours, 85%. 10 hours, 98. Okay, so there is the scatter plot. Now what they want us to do is determine the correlation. Now correlation, that means as you go to the right, Do the dots tend to go upwards or do they tend to go downwards? These particular points tend to go upwards, okay? Remember, it's a trend. It doesn't mean every point has to do that. It's just the general trend. As we go to the right, the dots are tending to go upwards. So we can say this is a positive correlation. Okay, so we're gonna go ahead and do that. Correlation, then it says to explain the meaning. What positive correlation means is that whatever your x is, as that increases, as you study more, okay, the hours that you're studying increases. As you study more, what else increases? Your test score. That's your percentage of your test. So as this gets bigger, so does this. As you study more, the test scores increase. Something along those lines. Now hang on to this graph because we will come back to it as we look at a problem on the backside. Okay, so that's what the deal is with study hours. Now they want us to do the same thing with TV hours. So I will go ahead and make a graph again. Okay, TV hours, the X value. The X values, okay, somebody watched 0 hours of TV. That's crazy in a whole weekend. 0 hours, the largest number is 20, so I can go by ones. This is TV hours watched, and that's over the weekend. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. Yeah, that's a 19. I was thinking about the next number. Okay, so that's the hours watched on TV. Our scores, they're the same result, the same test scores as our previous scatter plot. What's happening this time is now we're looking at the test scores based off of TV hours watched instead of studying. So I'm going to do the same percentages: 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. That is the percentage that they got on the test. So go ahead and make your scatter plot. 0 hours, 98 on the test. 1 hour of TV, 85 on the test. 2 hours of TV, 72% on the test. 2 hours of TV on the weekend, 90 on the test on Monday. 3 hours on TV, 67. 3 and 93, 3 and 95, 4 and 68. Anybody else think graphing's kind of relaxing? Not too bad at all. 5 and 76, I'm sure you all answered me. We're gonna go ahead, 7 and 75. 7 and 58. 7, oh, that's 7 hours of TV. I thought that was studying. Never mind. 9 hours of watching TV. 63 on the test Monday. 9 hours, 69. 11 hours, scored a 55. 12 hours, scored a 58. 14 hours of TV. 14 hours, got a 64 on the test. 16, got a 48. There we go. 17, got a 51. 18, oh, 18 was a 41. 19, 49. And 20, got a 40. Okay, so there is my scatter plot. Again, what they want us to do is identify the correlation. As our X value, as the amount of TV watched got larger, as you were watching more TV, what happened in general to the test scores? Well, they generally dropped. It looks like as you go to the right, the points tend to drop downwards. So this is called a negative correlation. Negative correlation, what does that mean? That means as whatever the X value, as that increases. So as you watch more TV, as this increases, this decreases. So as you watch more TV, the test scores tend to drop. Okay, now again, hang on to this. I'm going to let you choose which graph you use as we go over on the backside and we talk about a line of best fit, okay? When you have a linear model, and what that means is if you look at the correlation, it is either positive or negative. If it is no correlation, that means that there's no relationship. You can't draw what's called that line of fit in there because you have no idea where the line would go. But if it is positive or if it is negative, you can draw a line of fit. And what happens is you sketch a line that you feel appears to fit the points. So the cool thing here is that we can all draw what we feel is a good line of fit. We can all technically have a great line of fit, and all of our lines can be different. So that's what I really like about this. You get a little bit of freedom. You are drawing your own line. Now here, when we go ahead and do this, I said to use example 1. Then when we actually graphed it, that's going to be pretty darn tough. So what I want you to do is either pick your positive or negative correlation. I'm just going to go ahead and graph this negative, grab my negative correlation graph. Either one, because what we're going to do is just go through the process. Now, if you are going ahead and looking to see if you can draw a line of fit, you have to make sure that your correlation is positive or negative. I looked at the hours of TV watch, the amounts of hours that TV were watched based off of the test score. So we did have a negative correlation. That means I can draw a line of fit. Now here is your goal. When you are making your line of fit, you want it to fit the data. Ideally, you should have the same amount of points on either side of the line, okay? So if I go ahead and I'm making my line of fit, you want to have about the same amount of points above and below the line. So I'm going to go ahead and draw my line here. You go ahead, draw a line. I feel that this line fits the data. Okay, then, so it says sketch the line. Now what you have to do is find the equation for your line. In order to do that, you pick 2 points that are on your line. There's a really good chance you're going to have more than 2 points. I have this point touches, so does this one, so does this one, so does this one. Okay, so I get to pick. You get to pick as well. Pick 2 points that are on your line. So again, if you are finding a line of fit, you have to make sure your correlation is either positive or negative. You sketch a line that you feel fits the data. The goal is to have the same amount of points above and below the line. Once you draw your line, you pick 2 points from your line. My ordered pairs, I have 1 and 85. So the data point, this was the person who watched 1 hour of TV and got an 85 on the test score. The other one that I have is 20 and 40. This individual watched 20 hours of TV and got 40%. So what you're doing is you take those 2 ordered pairs. Now, if we are going to find an equation, you have to first find the slope. The slope, remember, this is x1, y1. This is x2, y2. To find the slope, it is the second y, 40, minus the first y. For me, it's 85. If your numbers are different, that's fine, because you have a different line than me. It's just the process. Second x, 20, minus first x, 1. If I take 40 minus 85, I have a negative 45. Over 20 minus 1 is 19. Now again, because you drew your own line, do not be alarmed if your numbers are kind of crazy. So I have 45 over 19. When I went ahead and put it on the calculator, it was pretty wild. I might actually just keep it as a fraction, okay? They did not say, what is the slope of your line? They said, find the equation of the line. So once you have your slope, you pick 1 ordered pair. Then we have to go to point slope form. So it's y minus the y value from the ordered pair you selected equals m. You should have calculated a slope. X minus the x value from the ordered pair you selected. Okay, so going back to that point slope form. Now we go ahead and distribute. So y minus, for me it's an 85. Negative 45 over 19 times x is negative 45 over 19x. Negative times a negative is a positive. 45 over 19 times 1 is 45 over 19. Last step, I need to add 85 over to the other side. So y equals negative 45 over 19x. When you add fractions, you have to have a common denominator. So 85, I needed to have a common denominator of 19. Now again, these numbers are not necessarily going to be the friendliest because you drew your own line. Okay, so in a way, you created your own poison. I gave myself 1,615 over 19 when I had to add that 85. My common denominator is a 19. Top numbers, you add them. So 45 plus 1,615. I have 1,660 over 19. Again, if your decimal ended up okay, you can always go into decimal form. But the big thing, when I go ahead and look at our directions, I just said pick one of the examples. Our example 1 really wouldn't have been too great because it was kind of a straight line. So take either your positive or your negative correlation from our second example. Identify the correlation. The reason you have to do that is because you can only draw a line of fit if it's positive or negative. Sketch the line, select two ordered pairs, use the two ordered pairs to create the equation. And that is it for 1.7 part 1. Talk to you guys later.